Alright, so thank you for joining. This is going to be another episode, I guess we'll call it, of Chill Skills Sporlan Web Talks. Today's lesson is how to clean up a system using Sporlan Catch-Alls. Okay, so just a heads up, we do have some more upcoming talks we'll be doing throughout the summer. In June, we're going to be talking about superheat and how to adjust TEV superheat. In July, we'll talk about how to identify a TEV. In August, we're going to dive into zoom lock. And then in September, we'll talk about operation and selection of solenoid valves. Okay, some administrative notes. If you do not have sound on your computer, we do have a phone dial-in. There's the AT&T dial-in and the participant code. Okay, if you haven't done so already, please mute your microphone, and we ask that you type your questions in the chat window. And for everyone's awareness, we are recording this webinar. Now, first and foremost, I want to introduce myself. My name is Henry Papa. I am a Sporlan sales engineer out of Florida. And if you have any follow-up questions or anything you would like me to send you, my email address is henry.papa, P-A-P-A, at parker.com. All right, so let's talk about the cleanup procedure after a motor burnout. Now, as you know, Sporlan has all the options for system cleanup if a motor burnout does occur. We have our sealed type catch-alls, our replaceable core types. We also have our test stalls, which is going to tell us the severity of a motor burnout. And we have our replaceable core type HH filter dryer cores, which are specifically designed for cleanup after a hermetic burnout. Now, first and foremost, how do we determine if a motor burnout has occurred? We want to check the resistance across the windings in our compressor. If we have any open windings, if we have infinite resistance, then we have had a motor burnout. All right, now that we have determined if a motor burnout has occurred, next we want to measure the severity. And that's where we use our test stalls, the TA-1 acid test kit. Now, the TA-1 is a one-time use. That's one thing we want to make clear. And it's going to be a pass-fail method, which is going to tell us the acid level inside of our lubrication. Now, the kit can only be used for mineral, alkylbenzene, and POE lubricants. And when testing for severity of burnouts, we're going to have two different classifications. Number one is going to be a mild burnout. And this is when the lubricant has little or no acid present, and the appearance of the lubricant is still satisfactory. So what is the cleanup procedure? Step number one, we are going to recover / save the refrigerant, or we could isolate it somewhere else in the system. Next, we will do our replacement of the compressor. Step 3, we're going to install an oversized catch-all in the liquid line. Now, when we say oversized, that means one step up. So if we're using a C-164S, we'll go up to a C-304S. All right, now that our catch-all has been installed, we're going to evacuate our system or the line set if we've isolated. We will recharge the system or open the isolation valves, and then we're ready to start up the system. Now, on critically charged systems that require, like a cap tube system, something that has a specific amount of refrigerant, we need to adjust our charge based on the volume that the catch-all can hold as well. And that information can be found on all the catch-all boxes. Now, our second classification of burnouts is a severe burnout. And this is designated by a system that has acid present in the lubricant and or the condition of the lubricant is suspect. If we've seen discoloration, we have carbon material if there's a specific scent to the lubricant. Also, if we do not know the acidity of the lubricant, we want to follow this procedure to be safe. So, like our mild burnouts, we want to remove the refrigerant. Next, we're going to replace our compressor. We will clean and or replace any control components like our expansion valves. Like in the mild burnouts, we are going to install an oversized catch-all, again, one size up. We also recommend installing a sight glass, a seal, preferably downstream of the catch-all if there isn't one already present. And because it is a severe burnout, we're going to want to install a catch-all suction line filter dryer as well. Or we could also use the replaceable shell type, the RSF. And before we finish talking about all the steps to severe burnout cleanup, we're going to look at the system overview. So at the top of the screen, you'll see we're using our testall at the compressor. We're pulling some of that lubricant out and testing it. For our suction line filter dryers, we're going to have it off the common suction to your compressor. You'll see our liquid line catch-all over here prior to the expansion valve. And this is ideally how we want our sight glass installed, right prior to the expansion valve. So the preferred placement is right up next to the expansion valve. And what that's going to indicate is that we have 100% liquid getting to our expansion valve. Okay. And a clear sight glass at this location will also indicate that we have a properly charged system. Another benefit to the seal is that it does indicate if we have moisture inside of our system. We have indicator paper which will change colors depending on how much moisture we have inside of the system. So when the indicator paper shows green, our system is dry. When it starts to turn chartreuse or an in-between green and yellow, that's when we should think about replacing our catch-all. We start to have moisture. Now when it is yellow, that means we are saturated with moisture. It's time to recover the refrigerant, pull a vacuum, and replace our filter dryers. A couple other colors that you may see if you are seeing brown inside of your seal, that could be a sign of contamination inside of the system. And also if you see black covering the actual glass of the seal, that's indication that when a sight glass was sweat in, that they overheated it. Okay, now that we've covered the seals, we want to talk about our suction line filter dryers. So the suction line filter dryer is the preferred method for cleaning up a system after a hermetic burnout. And here's just a couple examples of the kinds we have. These are both sealed types. And you'll see on the right we have the C-146 STT-HH, and that's a compact suction line filter dryer. And so that's ideal for tight spaces like a heat pump system. Now when we get into larger systems, just like we do with our liquid line, we have replaceable shell core type filter dryers. This is the RSF 4817-T. So any RSF-48 shells are going to take an RC 4864, which is the standard catch-all core. We also have that RC 4864-HH, again designed for hermetic compressor burnouts. And when you're using core types, we want to make sure we're also using the screen 6171-5. Now the third type of core that we have is the RCW-48, which is designed for high moisture absorption. Now if we are using these shell and core types for temporary, when we do replace the core with a pleated element, we want to make sure we discard that screen. Okay, now that we've talked about the rest of the components, the seals and the suction line filter dryer, let's finish up the procedure for a severe burnout cleanup. The last couple steps we're going to do is evacuate the system. We're going to recharge with new refrigerant, and then we're ready to start up. So when we're cleaning up smaller systems, catch-alls are rated so cleanup can be accomplished with just one service call. And again, if you have a critically charged system, you still have to adjust your charge based on that added volume of the catch-all. And again, we are only oversizing the liquid line catch-all. We do not want to oversize the suction line filter dryer. That can again lead to another compressor burnout. Now on larger systems, we want to check the pressure drop after the first hour. If it is high, according to these charts that we publish in our catalogs and our bulletins, we still need to replace the cores, and we're going to repeat this process. After the first hour of running, we want to check the pressure drop until it's sufficiently under these values. And one thing I do want to point out too is we've also added new refrigerants. We've added the 448, 449, and 513 to these charts. Okay. Now on larger systems, we want to check the acidity after 24 hours, and if the acid content is still high, we want to replace the cores and repeat the process. And then we are going to also check after 2 weeks until the system is now clean and we do not have excess acid. Okay, and lastly, I do want to hit on acid neutralizers. Though acid neutralizers can help reduce the acid inside of a system, we still highly recommend using both a liquid line catch-all and a suction line catch-all filter dryer. So the acid neutralizers have a low acid capacity, whereas the catch-alls will be able to absorb more of it. And it's also going to address any metallic fine particles and other oil breakdown byproducts because of a burnout. Okay, and that sums up cleaning up a system using a catch-all. We will get to any questions if you have any. Mario, you got any questions? Okay, looks like we have no questions. I want to thank everyone for their time for listening in today. And again, I'm going to put back up the agenda for summer web talks. Again, the next one will be June 26th. Have a good one, everyone.